All right. Good afternoon, everyone. Thanks for joining us for today's presentation hosted by the EPA to facilitate understanding of the 2013 Vessel General Permit self-sampling requirements. On the agenda today includes a brief presentation followed by a question and answer session. And I'll also note that we've muted all your lines except for the presenter's line. If you have questions during the webinar, we encourage you to type and submit questions using the GoToWebinar program. You can do this by using the GoToWebinar control panel on the right-hand side of your screen, and you may need to expand your control panel by clicking that orange arrow button. You will see a bold heading titled Questions. If you click the plus sign to expand the questions area, a text box will appear for typing and submitting questions to EPA staff. EPA, in conjunction with our presenters, will respond to questions at the end of the presentation. We probably will not be able to get to all the questions, but we will attempt to provide as much information as possible. We will be recording the presentation and emailing it to participants afterwards. And one final announcement, at the end of the webinar, a short survey will appear on your screen requesting your feedback on today's presentation. Your input is greatly appreciated. And with that, I will turn it over to Ryan Albert and Kate Kelly of EPA's Office of Wastewater Management to begin the presentation.
Thank you. First of all, thank you to everybody who is joining us today. We appreciate your time on a Thursday afternoon, and I think for many of you on relatively short notice. The presentation we're going to talk about today is tips for meeting sample collection and analysis monitoring requirements. This is a presentation that's really designed to be an introduction to self-monitoring, focusing on the logistics of taking samples and arranging for their analysis. So this is for those of you who have not conducted much monitoring in the past. We will not be getting into the details of complex ballast water monitoring for shipboard sampling or IMO type approval sampling or anything of near that level of detail. My name is Ryan Albert. I'm with the U.S. Environmental Protection Agency, and I'll be joined by three speakers who I'll introduce in just a moment. So briefly, to run through today's presentation, what we're going to do is we're going to go through and talk about the sampling requirements for the four significant discharge areas in the VGP. It's ballast water, bilge water, gray water, and exhaust gas scrubber effluent. And then after that, we're going to go through and talk about specifically two of those samples in detail in terms of how you collect those samples, and then also how you arrange for laboratory analysis of those samples in some more detail. We will not be going through and discussing ballast water sampling in detail today or exhaust gas scrubber sampling in detail because the type of message we would deliver is very similar for those samples. I do also want to note that today's information is generally a summary of some additional reference information that we're pulling together at EPA, and we intended to have that out today. Unfortunately, we do not have it to send to you today, but we do anticipate having it in the very near future, which will discuss everything we go through today in greater detail. So without further ado, I'm going to go through and introduce the speakers. First, we're going to have Kathleen Kelly. Kathleen is an environmental protection specialist with the U.S. Environmental Protection Agency. She has several years of experience working in the Office of Wastewater Management on programs and policies related to the National Pollutant Discharge Elimination System permitting. She helped develop the 2013 Vessel General Permit and is involved with implementation and outreach for EPA's Vessels program. In addition, Kathleen has worked with international community on issues related to Arctic shipping. After Kathleen, we'll be joined by David Wetzel, who will be speaking. David is the owner of Admiralty Environmental, an Alaskan-based firm that offers water and wastewater consultation, environmental sampling, and laboratory testing services worldwide. The focus of David's expertise is on water and wastewater systems from vessels, effluent monitoring for wastewater discharges from MPDS permit holders and large mining operations, and technical support for drinking water systems. David has been involved with monitoring cruise ships since the inception of the regulation of environmental discharges from ships in Alaska in 1999. Finally, we will conclude with Kathleen Wu. Kathleen is a chemist and environmental scientist with Eastern Research Group and has been with the company for the last 8 years. She has experience in environmental sampling, regulatory development, industrial process analysis, and water enforcement. She has supported the EPA's Vessel General Permit work since 2008 in all areas, and I'll throw in she's done a very good job of that, and has personally sampled from over 50 vessels of various vessel classes and discharges. So thank you, first of all, to all of our participants for speaking. Finally, before we get started, I want to mention today's webinar is being sponsored by the United States Environmental Protection Agency. The speaker's thoughts are their own and do not necessarily represent the position of the EPA. In the event that any information in today's webinar conflicts with the terms spelled out in the VGP or the VGP fact sheet, those documents govern. The final thing is we're getting ready to go to a poll question. Throughout this presentation, we'll have several poll questions, and we would love it if you would take the time to answer the question. We will read the results during the course of this presentation. So now I'll turn over the poll question, and immediately after that, we will go to Catherine.
So hi everyone.
I'm sorry, go ahead.
Hi everyone. So you'll see on your screen there's a poll question. If you could please answer it quickly, and then we'll push the results live in just a few moments. Okay, and we have about just over 80% of you responded, so I will close the poll and go ahead and share it with you all. Okay. And did we want to go straight into the second poll?
Yeah, go ahead.
Okay. So if you wouldn't mind answering one more poll question for us right now. Okay, and we have a great response rate. Looks like 90% of you have responded, so I'll go ahead and close that and share the results. Okay, and then I'll turn it back over to the presentation.
Great, thank you very much. This is Catherine Kelly with the EPA. I'm going to go ahead and get started in talking about the monitoring requirements that are a part of the VGP. As Ryan mentioned, covering the 4 major areas that require monitoring: bilge water, gray water, exhaust gas scrubber, and effluent and ballast water. So the first section that I'll talk about is bilge water monitoring, and this is part of the VGP section 2.2.2. So this is a new requirement for the 2013 VGP, and this applies to new build vessels. Those are vessels that are constructed after December 19th of 2013 that are greater than 400 gross tons. So for these vessel owner-operators, they must sample their bilge water effluent once per year. And each sample must be analyzed for oil and grease content either using EPA method 1664 or ISO method 9377-2. So in addition, as I mentioned, it's an annual monitoring requirement. However, there is a reduced monitoring option available for basically if you have analytical results that show an oil and grease concentration of less than 5 ppm for 2 consecutive years, and you meet some other conditions, such as you have an OWS that's capable of meeting a 5 ppm limit, you calibrate your OCM annually, and that your OCM never reads above 5 during the discharge into water subject to permit. Basically, if you meet those conditions and have 2 years of less than 5 ppm, then you can be done monitoring for the duration of the permit term. Otherwise, you would have to continue to monitor once per year for the oil and grease content. So the next area, gray water monitoring, this is in section 2.2.15. And again, this is a new requirement for basically not the cruise ship fleet, but for new build vessels, again, constructed after December 19th of 2013. That have a maximum crew capacity greater than or equal to 15 and provide overnight accommodations to the crew. And it also applies to Great Lakes vessels subject to Part 2.2.15.1 of the VGP. So for these vessels, owners or operators will have to sample their gray water twice per year and at least 14 days apart. For this, each sample must be analyzed for biological oxygen demand, or BOD, fecal coliform, or E. coli, suspended solids, pH, and total residual chlorine. As I mentioned, there's also gray water monitoring
required for medium and large cruise ships. This monitoring is fundamentally similar to the 2008 VGP with some new additions for nutrient monitoring. So this requirement on your screen is primarily is for these new build vessels or non-cruise ship vessels. Okay. The next section is wet exhaust gas scrubber effluent. So this is section 2.2.26 of the VGP. And this monitoring is required for all vessels that are operating using an exhaust gas scrubber system that has a wash water effluent. So just a point to note, this excludes inert gas scrubbers as part of the safety system. This is just for exhaust gas scrubber systems. These samples must be collected from each of the following stages of the operation. So there are 3 different stages. The first collection is for the inlet water. The second collection is for the water leaving the scrubber but prior to treatment. And then the third point is for the discharge water, or basically the final effluent after any treatment has been used. So vessel owner operators would need to sample these points twice during the first year, at least 14 days apart, and then once a year after that. Each sample must be analyzed for dissolved and total metals, nitrate, nitrite, PAH, pH, and total residual chlorine. In addition to these annual monitoring, there's also a continuous monitoring requirement for exhaust gas scrubber for things for parameters such as pH, PAH, turbidity, and temperature. And finally, the last area I'll talk about for monitoring requirements in the permit is in section 2.2.3 for ballast water. So this monitoring is required for all vessels using a ballast water treatment system. And there are 4 major types of monitoring. There's functional monitoring, calibration monitoring, biological monitoring, and active substance monitoring. For biological monitoring, the second bullet, vessel owner operators must sample their ballast water twice during the first year, at least 14 days apart. And then potentially a reduced volume after that if you're using what we would consider high-quality data. So it's twice during the first year, and then you may reduce if you are using a system that we've categorized as high quality, having high-quality data, which means data that is, we believe is transparent, and this typically we're going to see that with systems that have U.S. Coast Guard type approval or AMS certification. For these samples, each sample must be analyzed for total heterotrophic bacteria, E. coli, entero, and by relation total residual chlorine. So I also mentioned there's active substance monitoring. So for ballast water systems that use active substance as part of their treatment process, there's a monitoring requirement for the discharge of any residual biocides or derivatives used in the treatment process. And then, as I mentioned, there's also functional monitoring, which is monitoring that's going to ensure the system is operating properly. It's required at least once per month for specific parameters, and it depends on the type of system you're using. For example, UV or filtration system will have system-specific functional monitoring. And finally, there's also calibration monitoring, which must be done annually or no less frequently than recommended by the manufacturer. So that's the overview of the requirements in the VGP. And next, I'm going to turn it over to Dave to get started on the presentation.
Just before we go into that, did we want to go ahead and do the poll?
Let's do the poll question.
Okay. All right. So one more poll question for you guys. If you could just answer quickly, and then we'll move right on to Dave. Okay, just have a few more seconds here. We've gotten about 50% of the vote right now. Okay, and I'm going to go ahead and close and share the results. Okay. All right, back to the presentation. Go ahead, Dave.
Thank you. I'm going to pick the discussion up with talking a little bit about how to create a plan for the sampling of your ship, how to choose a laboratory to do the testing of your samples, and then discuss some of the specifics about gray water testing, since that applies to quite a few vessel classes. Essentially, once you have looked at the permit and decided what type of discharges might apply to you, you really have your choice at that point of either self-sampling or contracting out with a laboratory or sampling contractor that can assist you. It's important to plan ahead and choose the option that's going to be the most convenient and efficient for you at this point. Although the EPA doesn't require a certification for vessel testing under the permit, a quality lab will participate in at least one of these programs that we have listed. There are several certification programs out there, including the National Environmental Laboratory Accreditation Program, individual state certification programs, and also the Coast Guard Laboratory Accreditation Program, which is abbreviated CG-MIX. These all identify labs that have been certified for vessel sampling and testing. So, you know, it's a good idea, obviously, that when feasible, to select a lab that participates in any one of these programs. Next slide, please. With your selection process with the laboratory, if you choose to go that route, prior experience with ship sampling and analysis is advisable. The whole field of ship sampling is a fairly new area of environmental monitoring, so this is a good place to really try to select someone that's got some experience. Not all of the contractors are familiar with the ins and outs of ship sampling. Although it's fairly straightforward, sampling ships have some unique components that are not associated with other environmental work. First of all, there's our security issues with boarding the vessel. Access to sampling points can be sometimes difficult. Most of these locations are going to be what you'd consider an industrial setting in the engine rooms of ships. So there are also some safety concerns that go along with either your ship staff that's going to perform sampling or bringing outside contractors in. And once again, the more familiar a contractor is with the permit and the analytical methods and just being on the ship itself, the more likely that your sampling is going to be successful. Next slide, please. So labs can often provide many services other than just testing, and some of these can include assistance with interpretation of permit requirements. They provide sampling equipment, including all the bottles, coolers, and paperwork that's necessary. In a lot of cases, like I mentioned, they can perform on-site sampling, do the field testing for you, provide transport of the samples to the laboratories that they're going to do the testing once it's completed. They can perform this analytical testing of your samples and then the reporting and the data management aspect of things. Not all laboratories offer field sampling, so that's something you're going to want to try to determine ahead of time. And once again, it's really important to inquire on the experience of any kind of firm that you have assist you beforehand. Next slide, please. Next, let's talk about some items to determine before you contact a qualified laboratory, because these are the questions that they're immediately going to ask you once you inquire about their services. First of all, you know, they're going to ask what kind of discharges are going to require sampling, so you should be fairly clear on that before you start the conversation. Each discharge, like was mentioned earlier, is probably going to have a different type of analysis that occurs on it, so it's good to know that beforehand. Each of these tests also is going to probably require a special type of bottle, a different type of preservative, so these are questions that are also going to come up. You're also going to want to make sure that the laboratory that you're discussing this with can cover all the different tests that you're going to need. Each laboratory out there, depending on their certifications or their scope of work, may or may not cover all of the components of each type of sampling. Also, it's highly important that you've already assigned or figured out a discharge point for any kind of sampling that you're going to be doing. In most cases, this has already been done during the construction of the system, but we have attended vessels sometimes where maybe a sampling port was identified early on a diagram, but it doesn't exist. So it's really important to confirm that before you do arrange for sampling, that you have an adequate sampling port to draw a sample. And then it's also important to coordinate with specific port locations as far as where the ship is going to be docking, and also identifying lab services within those areas. Some locations in the world are more amenable to sampling than others, as far as proximity to laboratories, the type of security that you have to go through for getting contractors on and off the ship. And another good component is that it's advisable to identify one person on your vessel or within your organization who will handle this program, whether it's your environmental officer, your engineer, your chief engineer, but put one specific person in charge of this. Next slide, please. And then in turn, you should also have a list of questions to ask the laboratory to determine whether or not they're going to be a good fit for you. First of all, you want to find out if the laboratory is qualified to perform all the analyses that your vessel is going to require. You want to find out what kind of experience the lab has in analyzing vessel discharges. Once again, not all labs do all tests, and this is a fairly new area of environmental monitoring, so these are good questions to ask. All good laboratories that participate in these certification programs should have a comprehensive quality assurance or quality control program. It'll be good to inquire about this. They'll also most times be willing to offer you their quality assurance manual, and you can review that and determine what kind of procedures they have in-house. Laboratories will also provide adequate bottles and equipment for you for sampling. These bottles should be new. They should be certified as either clean or sterile, so that's something to inquire before you set this up. If you are going to be doing your own sampling, or if you're contracting with them, the laboratory should have a plan for picking up and delivering samples to where they need to go. So these are good things to work out ahead of time. It's generally a better idea to have the lab or the contractor handle all of this rather than have a courier that's in between this process. Part of the paperwork that we'll discuss later is the chain of custody that goes along with all samples to create a legal chain, essentially, of who's been in possession of the samples. So the less times we have to show a transfer of this, the better. And then last thing you want to find out is what the timeline is for laboratories to test your samples and report data to you. A normal turnaround time should be anywhere between 10 and 15 days, but that's also something you'd like to get established beforehand. Next slide, please. So now going into gray water and some of the specifics of that, you can't really emphasize enough that either the samplers or contractors you have or your onboard ship staff should be really well trained in collecting samples, the kind of preservation that goes along with it, how to handle samples, and then also details of the EPA permit and what kind of results you're going to be looking for. As discussed earlier, the monitoring requirements really vary depending on the vessel construction, what type of vessel it is, so you really want to check with your permit before you determine what type of gray water sampling you're going to need to do. And then coordination with your laboratory contractor is really highly important, just to make sure that samples get delivered on time. Once again, it's really important just to ask about the experience of your contractor and determine whether or not you think that they're going to be capable to perform this work for you. Next slide, please. So in preparing for sampling for gray water, it's important to determine the frequency of your sampling to determine the best time for collection. You want to really be familiar with the operation of your gray water system and also be confident in your ability to deliver samples to the lab at the time to commence analysis. Oftentimes the operation of a gray water system, the quality of that may vary over different parts of the time of day, so the more familiar you are with optimal times for collecting samples, the better. We'll discuss this a little bit in the next slide, but each component of the equipment, paperwork, and bottles that are associated with sampling is very important. So you want to really review the list of what we're going to talk about beforehand. The good thing about gray water sampling is that it can either be performed while the vessel's underway or in port, provided that your effluent stream is sampled in a representative manner. But you really want to be careful to know the operation of the system. For instance, you want to avoid sampling a gray water system immediately after you perform maintenance or desludging of the system, something like that. So, you know, that's why in some cases it's good to have an engineer who's involved with the process and coordinating of the sampling. One thing that we'll talk about as we get farther along with some of the tests as well is that really the holding times for the tests that you're going to be doing on your water really dictate, excuse me, the best time for sampling. The shortest one, and I guess to explain holding times a little bit better, this is the maximum amount of time that can elapse between the collection of a sample and the start of a certain test. The shortest one that you'll really encounter for gray water that has its test that should be done in the lab is for fecal coliform or any kind of bacteria. And this time is 8 hours. So a lot of the coordination of your sampling is really going to depend on your ability to collect a sample and then have the laboratory commence that test within 8 hours. Each of these tests have their specific holding time, and each of these really need to be met for results to be acceptable. Next slide, please. So let's list through here some of the equipment that's really essential for gray water sampling. First of all, obviously, sample bottles. You'll be getting these from the lab. Each test is likely to have a specific bottle type, although you may see some bottles that can accommodate 2 different tests if they have a like preservative. Let's say biochemical oxygen demand and total suspended solids are often taken out of the same bottle. You'll have your field test equipment, which we'll talk about in a minute, for things like pH and chlorine. You'll also want to get a large bucket, which is going to be used to collect water that you flush through the sampling port. This is really important, and we'll talk about it a little bit more as well. But in order to really collect a representative sample from the sampling port, you don't want to have any residual contamination in the sample port itself, so flushing is really important. The lab will provide bottle labels as well. And one point here is that oftentimes it's advisable to request the lab to send the labels separately from the bottle so that you can fill those out before they're actually on the bottle itself. It's a lot easier to write on a flat surface than to try to write on a bottle. Pens are, obviously important there. We like to use pens with blue ink so that we can tell the difference between original copies and photocopies. So if you are using pens for your CSCs, blue ink is good. Disposable gloves are important. We found that the best ones to use are nitrile gloves that are powder-free because if there is any kind of metal sampling component that goes on, the powder in those gloves can often contain zinc, so that can be a source of contamination. And then just going down the list, some of these bottles may contain a preservative, and you'll work with the lab to determine which bottles need preservative, but it's a good thing to have them put that in there beforehand. A logbook to keep track of the sampling event and any kind of things that happen. You want to have, if there are any kind of glass bottles involved with your sampling, oil and grease is a test that would require this. You want the lab to provide some sort of bubble wrap or padding to make sure that those don't break. And on down the list, just including the adequate paperwork, garbage bags for any kind of, to wrap up the samples and for any waste that's generated. The tape would be used mainly to seal coolers at the end of the sampling event. And then the samples really need to be chilled in most cases, so some sort of hard-sided cooler is really ideal for collecting samples. Chain of custody forms will be provided by the laboratory, and this will be a record of who's had control of the sample from the time it's collected until it's analyzed. In some cases, if you're unable to observe the cooler or have it in your possession the entire time, a custody seal on the lid of the cooler, it can be a good way to show that no one else has had access to those samples except yourself. Next slide, please. So taking a representative sample of gray water is very important. I mean, in order to really accurately evaluate the gray water discharge, you want to try to take a sample that really best characterizes how that system is working. An important part of this, obviously, is that you need to have a sampling port that is going to deliver you a representative sample. In most cases, this is going to be as close to the overboard discharge as possible. If you do have a UV system installed, obviously the port should be after the UV apparatus, particularly because microbiology is involved. If you are collecting samples for microbiology, it's often a good idea to sterilize the port prior to collection. Some vessel owners use either heat to heat up the sampling port for sterilization or maybe spraying with alcohol. Either one of these is good. As we just talked about earlier, adequately flushing the sampling port is also important. You don't want to have any type of residual contamination in your sampling lines. So generally flushing, 5 to 10 liters of water through a sampling port prior to collecting a sample is a good idea. Because it's really important to remember that the sample is really only as good as the manner it was collected in. So as much work as you can do to make sure that your sample is clean and that it represents what's going on with your system better. Next slide, please. So field tests performed for gray water. The tests of pH and residual chlorine really need to be collected within 15 minutes of tested within 15 minutes of sample collection. Both of these parameters really change rapidly immediately after a sample is collected. So this is really only appropriate for you if you're doing your own sampling or for the sampling team to do right away. This type of testing is done with calibrated specific meters for each test. For chlorine, generally they're using what's called the DPD method of test for chlorine, and there's a powder that's added to the sample that turns pink in the presence of chlorine. These meters generally have a fixed calibration, so you'll just be doing tests and these meters will kick out a number that gives you a level of chlorine. But if you do see results for chlorine that are quantifiable, there should also be a pink color that's associated with that. As far as pH goes, there are also handheld meters that are adequate for this, but pH meters generally require frequent calibration, and this is very, very important to maintain a log of this and to perform these frequent calibrations in order to get accurate pH results. With both of these field tests, it's also really important to clean equipment in between samples so that you don't transfer any kind of contamination or influence the test anyway just because of something that was done previously. And then these two samples are unpreserved, so generally these are collected in a 1 liter container without preservative and then analyzed right away. And these meters are generally available online. There are several manufacturers that produce these, and you can get decent meters for not very much money. So, but once again, there's plenty online where you can reference these methods and take a look. Next slide, please. So if microbiological testing is going to be performed on gray water, it's likely either going to be a test for either fecal coliform or E. coli bacteria. These particular parameters have been prone to contamination in the past during sampling activities, so it's important to really be as sterile as possible while you're doing the collection. But these tests have to be initiated within 8 hours of sample collection, so this is where coordination with the samplers in the laboratory is really important. Once again, using clean techniques, clean bottles. Most labs will have commercially prepared sterile bottles, and these often have a seal, so it's good to look for that when you're observing the sampling going on, just to make sure that the lab is using clean bottles. Another important component of microbiological testing is that the samples have to be cooled immediately and kept cool between the time of sample collection and analysis. These bacteria reproduce highly rapidly at engine room temperatures, maybe even once up to every 15 minutes. So it's really important to cool these samples quickly and then to stop any kind of growth of bacteria after the sample is collected. Next slide, please. And finally, reporting results for gray water. You know, at this point, you've determined that the lab's capable of producing reports with quality control information. These will be provided to you on the conclusion of analysis. Most laboratories do this electronically. In a lot of cases, you could also request that they send reports in Excel format, which will then make data transposing easier for you. Your next step will be to assemble that data on your discharge monitoring report forms, and this will become part of your vessel annual report. In the meantime, any kind of monitoring activities that you do and information needs to be kept on board the ship for 3 years, and includes the list of these following items, which is the date, place, and time of the sampling or the measurements, the individual who performed the sampling, the individual who performed the test, and any kind of calibration of your meters, the complete analytical results and QC information, any kind of techniques or methods that were used for the testing, and then the results of those analyses and things like OCM readings. So once again, this is where your logbook can also provide that type of information, and it's something good to keep on hand as well. I think that's the last of my slides.
Okay, this is Kathleen. I'm going to be talking about bilge water sampling and more specifically the oil and grease samples. And we're going to assume that you have not contracted out someone to do your sampling and that you'll have someone in-house, like your personnel, doing the sampling for you. So the first step for bilge water sampling is going to be selecting the method, and EPA has allowed 2 different methods for analysis of your oil and grease. And we'll go through both as we go through the process of sampling. So the first method is your 1664, and it's your hexane extractable material method. And this is typically used by EPA for the Clean Water Act. And so it's going to be more commonly offered by commercial labs in the U.S. I do have to mention that along with this, there is a silicone gel-treated portion of this, and it's not required by EPA for BGP sampling. So you'll have to clarify with your lab that the Sargent hem portion isn't needed. The second method is the ISO method, and this method is typically used by the U.S. Coast Guard for type testing approval of bilge water treatment systems. So you're more likely to get consistent results with their sampling. However, this method is typically more expensive and not as prevalent in labs. Once you've decided the method you want to go with and have an idea of what lab you want to go with, you're going to want to start assembling the equipment that you need for sampling, and it's primarily consisting of equipment that you'll need to use to take the samples, to preserve the samples, and then transport the samples to the lab. So Dave has gone through some of these. We've got bottles and gloves and preservation chemicals, pH paper, a thermometer, various bubble wrap, garbage bags, zipper bags, tape to keep things from leaking and breaking, a means to cool the samples, whether you plan on putting the samples on ice or putting it in a refrigerator, and coolers for transport. And then the other set of equipment is going to be your paperwork, which includes bottle labels, field notebooks, your chain of custody forms, shipping forms, and custody seals. The next 2 slides, we're going to talk about taking a representative sample. First, you're going to definitely want to talk to your lab and see what sort of QA and QC samples they recommend. Typically, there are 2 types. There's the duplicate sample, and then there's the sample blank. So the duplicate sample is just purely a second set of volume for your sample. So the lab runs everything twice, and that way you get a more accurate result. And then the blank sample is actually a bottle of HPLC water, which stands for High Performance Liquid Chromatography water, and that's really, really clean water that a lab will provide you, and you basically take that as if that is your sample and use the same equipment and the same personnel and go through the same steps. And the purpose of that is to see if there is any contamination in your final result. So the other things you'll want to do while you're sampling is also consider taking the sample during normal operations of your oil water separator and ensuring that there's adequate flow. So you don't want to take one sample one day, realize there's not enough flow, and have to take it another day. And then immediately after taking that sample, you'll want to take your oil content meter readings as well. So some thoughts on good sampling techniques, and this is primarily, again, to ensure that your samples are accurate. You'll want to use clean bottles provided by the laboratory and cleaned by the laboratory. These bottles should all be labeled with waterproof ink so that after they've been sampled, you know exactly what they are. You'll want to use a latex or nitrile gloves to avoid contamination. And you'll also want to avoid touching the inside of the bottles, opening the bottles when you're not taking a sample, or leaving it open. Those are all ways to minimize contamination. Once the sample has been taken, if the sample is hot, in terms of temperature, you'll want to let it cool down to room temperature before putting it on ice to avoid glass shattering. And you'll want to be very diligent about taking field notes. You want to note any deviations you made from your original plan, anything that you think the lab should know, the date, time, location of the sample, your OCM readings, and then any notes for personal future reference. So now that you've taken your sample, the next step is preserving your sample. Both methods we have laid out here are their preservation requirements. Now both need to be cooled to less than 6 degrees Celsius. And the best way to do that is actually to use a temperature blank. And that's just a separate bottle containing water that accompanies your sample. So if your sample is being put on ice, you put that bottle on ice as well. If it goes into a fridge, you put that in the fridge as well. And then what you would do with that temperature blank is measure the temperature of that instead of your actual sample. And that's to avoid, sticking a dirty thermometer into your sample and contaminating it yet again. So for the ISO method, that is the only preservation requirement. For your EPA method 1664, there's an addition of either hydrochloric acid or sulfuric acid until the pH of the sample is less than 2. Now, I would recommend talking to your lab and having them pre-preserve your bottles for you. And now, what that means is that the acid is already in the bottle when they send it to you. And they'll determine the volume and how much you need. The other option is have them provide you with the acid separately. There's a photo of what these acids may look like. And they'll also tell you how much to add. So that is something you would do in the field after you've taken the sample. So now you've taken your sample and you've preserved everything. The next step is to complete your chain of custody form. Now this should be information you already know based on your bottle labels and your field notes. And this is something that is to show the written record and to be able to use this as a way to trace the creation, the possession, and the handling of the sample. So it should have all the information you would need to know about any sample. So that would be, what is this a sample of, what discharge is it, when was it taken, the number of bottles it's in, what's been put in as a preservative, anything like that. And a copy of it should always be with the actual samples. So I would recommend that the vessel keep a copy of it, but the original chain of custody should stay with the samples. So if you pass it on to someone, say a courier service who's taking it to the lab, they also need to sign off that they've taken it and that you've released it to them. Other important records include shipping forms, and we'll talk about that in the next slide. And the last one would be the analytical results that the lab provides you at the end. So shipping and transportation. Let's remind ourselves that for each of these methods, there are holding times that vary quite a bit. The EPA method 1664 has a 28-day hold time, whereas the ISO method has 4 days. So you'll have to think about logistically how you're going to get your sample to the lab within those hold times. And that might impact which analysis you select. So the easiest way to go about transportation is definitely through personal delivery or a courier service. So the samples are taken from your vessel either from your crew or someone at the lab and delivered directly to a lab personnel. If you're not able to find the lab within driving distance, for example, of the dock you are at, your only other option would be to ship. And there are a lot of considerations to make when shipping. One is that you'll have to definitely use overnight service. And you have to keep in mind that the samples have to stay at less than 6 Celsius during the entire shipment. So you couldn't use ground or have like a several-day shipping lapse because the samples will heat up. And if they arrive at the lab at the wrong temperature, then it technically did exceed the whole time. The other consideration is that the samples, when shipped overnight, have to be in the leak-proof cooler. So all your samples need to be in Ziploc bags, bubble wrapped, and all the ice should also be in Ziploc bags, and nothing should be leaking. Definitely consider using custody seals to ensure that the samples aren't tampered with during transport. And keeping in mind that the chain of custody forms do need to follow the samples, and so a good idea is to put that in the Ziploc bag as well to keep it from getting wet. So assuming you've taken your sample, done your preservation, you've gotten it to the lab within its holding time, now the lab has reported its results to you. At this point, you'll be reporting the results you've gotten to EPA, and you should know all of this information based off of either your field notes, your chain of custody, the copy that you've retained, and the analytical results from the lab. So this is just a list of the requirements that EPA has for bilge water monitoring reporting, in addition to a copy of the actual lab results. And I won't go through all of these, but there is an example of the monitoring form in Appendix H of the VGP. So basically, Dave and I walked through gray water and bilge water sampling, and you'll have to make these same considerations when looking at ballast water and exhaust gas scrubber as well. We will take some questions at this time.
Great. Thank you very much, Kathleen. So we'll go through and start scrolling through some questions. To those of you who have remained, and actually it looks like everybody has, thank you very much. We're going to go through the questions. We have quite a fair number of them coming in, so we may not be able to get to everybody's questions today, but we'll do our best to answer as many as we can. I would go on and encourage you, if you have questions at this point, go on and type them in, and what we'll do is we'll read through them and try to select a few questions and hopefully try to get at least one question from every person to the extent we can. So I'm going to start with the first question from Kathy. And the question is, and Catherine Kelly will answer the question, what are the expectations for a vessel which rarely, if ever, calls to a U.S. port, which suddenly finds itself headed to a U.S. port? Keeping in mind the vessel may receive their change in orders at a port without suitable analytical labs, or even worse, while at sea, can the vessel schedule the necessary sampling and analytical testing at its first U.S. port of call? So, Kate?
Thank you, Ryan, and thank you, Kathy, for the question. So yes, absolutely. I think we would recommend that if you were coming in, we understand that this situation happens, that you get diverted and you don't have a lot of time to plan. So the requirements in the permit are that you have two, in some cases, 2 or however many samples you needed to be done during that operating year. So absolutely, if you're coming into U.S. waters unexpectedly, you can plan to have that sampling done at that U.S. port, and we would recommend that. So again, you can have that scheduled as you're coming in and can do that then.
Sounds great. Thank you.
Thank you.
Okay, so the next question, and David, I'm going to direct this your way. For vessel owners and mariners that are not experts in the fields of sampling and laboratory analysis, are there some general rules of thumb that can be used to identify an acceptable laboratory in a particular port?
Well, I think you could go back to looking at whether or not the lab participates in any kind of certification program, and really using that list of questions that we had earlier on about things to ask a laboratory. I think once you get through most of those, you'll probably come to a point where you have a confidence level that the lab knows what they're doing and are able to provide that kind of service for you. You know, the other thing you can do is discuss this with other vessel owners who may or may not have used that contractor to see if they had a positive experience or they got valid data from that particular place. But really, that list of questions is probably a good guide to feel it out and see if the lab's going to be able to perform for you.
Great, thank you. So the next question I have for Kathleen. Is it common for laboratories to send complete sampling kits with preservation, bottles, and any other needed equipment, so basically the vessel operator just has a turnkey operation?
I would say there are definitely labs out there that provide that complete service. The first priority would definitely be to make sure that the lab does provide every analysis that you would need, and then the next step would be to ask about whether or not they have that complete kit. So they are out there, yeah.
So in other words, if somebody wants to do the 1664 test and doesn't want to have to add their own sulfuric acid, they can request the lab to do that.
Yes, and even if labs don't advertise that, definitely inquire about it, because those are things that they could easily do, and maybe they don't realize how much that would be of a help for you.
Great, thank you. Okay, so the next question is going to go to Kate Kelly. Does the lab have to be in the United States?
No, it does not, actually. So the requirement of the permit is that you monitor using an approved method. We laid out some of the method options, for example, EPA method 1664. So in that instance, no, the lab does not have to be located in the U.S. They just have to be able to conduct that particular method.
Great. Thank you, Kate. So the next question for Dave, and I'm going to read this first, Dave, as the way the person asked it, and maybe phrase it more or look for an answer more in general advice from you. The question is it necessary for the lab to be close to the location where the sample was taken? And then I will kind of add to that, is it necessary or perhaps is it advisable for the lab to be physically close?
Well, I think it's advisable, but it's really going to depend on what kind of testing you're looking for and the holding time for that test, and whether or not you're able to keep the sample under preservative conditions, let's say keeping it cold enough between the time that you collect it and when you get it to the laboratory. I mean, we work with several labs that are an hour away from the port, but they have an adequate plan for getting to the port on time and getting the sample back to the lab. So it's really driven by the holding time of the test that you have and what kind of coordination you can do with the lab.
Great. Thank you very much, Dave. The next question I'll take myself, and it is, could we please show the slides again which say which vessels are required to carry out the tests? And so first of all, I'll say regarding the slides, you will be provided a link to the slides at the end of this presentation regarding the specific requirements of laying out where you need to find in the permit itself where it discusses who needs to monitor. You can find that under the sections of the permit for bilge water, for gray water, for exhaust gas scrubber effluent, and then of course for ballast water. And then I will immediately tie this into the next question of, and I'll direct it to Kate Kelly, can you better clarify for gray water and bilge water samples who must actually conduct monitoring?
Sure. So both the bilge water monitoring and the gray water monitoring requirements are for new build vessels. Well, here, I'll step back. Bilge water monitoring is required for new build vessels greater than 400 gross tons. And for that requirement, you are new build if you were constructed on or after December 19th, 2013. I recommend you look at our definition of what constructed means, because it does mean that the keel was laid after that date. I think we had another question that touched on that as well. So So if you are a new build after December 19th of 2013 and you're greater than 400 gross tons, for bilge water, you will have to conduct monitoring. Everyone else does not have to do bilge water monitoring under this permit. For gray water, it applies to new build vessels after December 19th of 2014, as well as some Great Lakes vessels that are subject to 2.2.15 of the permit. So again, for the new build requirement, it's triggered by the same thing if you were constructed after December 19th of 2013. There's also a caveat that if you have a maximum crew capacity greater or equal to 15 and provide overnight accommodations. So again, we recommend look at those sections of the permit to see, specifically whether or not this would apply to you. But generally, this is going to apply to new build vessels. And also to say there is other additional gray water monitoring that would apply to medium cruise ships and large cruise ships.
Great, thank you. And just while we're on that subject, there's another question here that's a very similar question, but ask the question for exhaust gas scrubber effluent. Do only new vessels need to monitor exhaust gas scrubber effluent?
In that case, it's all vessels that have exhaust gas scrubber systems. So we don't distinguish whether or not you're a new build vessel or you're an existing vessel. If you have an exhaust gas scrubber system that has a wash water effluent, then you need to monitor. That one's a little more general.
Great, thank you. We'll take Kate off the Inquisition block now and switch over to Kathleen. What happens when the lab technician exceeds the holding time because they didn't get the samples back to the lab in time, i.e. had other sampling jobs on the way? There would be a quality qualifier that was not under the control of the client or the owner. So Kathleen?
So I think in that situation, and it's assuming it's the fault of the lab, you've got two options. One is to have them run the sample as is, and in their analysis report, it would note that this analysis was run, this is the result, but it was done exceeding the hold time. And it should indicate how much of the hold time it did exceed. And then your other option, of course, is to have the lab perform the analysis for you again for free. You'll have to, of course, collect the sample, get the equipment, and redo all that stuff yourself as well again. But the lab should be able to, you should request that they perform the analysis again within the hold time.
Great. Thank you, Kathleen. So the next question back to Kate. Are Great Lakes bulk carriers that classify as commercial vessels and do not discharge gray water overboard required to do any gray water testing at all?
So this is kind of can be applied more generally while I answer this. If you do not discharge that effluent stream, you are not required to do monitoring. So in that instance, in that scenario, you had a Great Lakes bulk carrier, but that did not discharge gray water. Therefore, they would not be subject to gray water monitoring. And this is actually, I'll caveat this a little bit too, or not caveat, expand on this. So this is a question we get from a lot. If you, for example, for bilge water, if you're a vessel that does not discharge bilge water within waters of the U.S. or within 3 nautical miles, do you have to do monitoring? And the answer there, again, is no. So if you are not discharging the effluent stream, you are not required to do the monitoring.
And just to clarify, so that you don't have an EPA our compliance folks knocking on your door after 2 years, just be sure as part of your annual report you just check that you did not discharge that monitored stream into U.S. waters. A second element of that question that I'll try to tackle here today is also the element of if you're a commercial bulk carrier discharging gray water in the Great Lakes. So if you are actually discharging gray water. Actually, I don't think you can discharge gray water in the Great Lakes because you should typically, that most of it would have no discharge zones as it's part of sewage. But if you were to, you would be subject to Section 312 of the Clean Water Act and not this permit. However, if you are a vessel in the Great Lakes that's subject to the VGP, you would, and you are not, and your gray water is not subject to 312, you would have to conduct monitoring if you discharge that gray water. Now, we expect that to be a universe of 0 vessels, but there may be a couple out there. So that's just an alert there. If you have questions about that, send us a question to our VGP box. We'll discuss at the end here. Great. So the next question is back to Kate again. Will the EPA, Coast Guard, or the states be regulating this program?
So So this program would be regulated by EPA. So you would be submitting this monitoring data to us as part of your annual report.
Okay, great. The next question for Kathleen, you talked about a little bit during the course of your presentation, but can you discuss some of the pros and cons of the two methods for oil analysis that you went through in your presentation?
I would say the ones that definitely stand out are the fact that the prevalence that is offered in laboratories. So I think I mentioned that the 1664 method is more prevalently offered by U.S. labs. The other thing to consider is definitely the hold time. The 1664 method has a 28-day hold time, whereas the ISO method has a 4-day hold time. So if you're unable to find the lab close to the dock you'll be at, I would definitely go with the 1664 so you have adequate time to ship the samples and still meet the hold time.
Great. Thank you. So the next question from Jonathan. In the response to comments document, EPA states that any sampling conducted to demonstrate compliance must be reported annually, while sampling conducted to verify maintenance and operational status would not necessarily be required for submittal. Can you elaborate on the distinction? And I'll take that question, John, and I would throw out there, I have to go back and look at the specific context of that response, but my guess would be we were thinking more in the light of monitoring such as your routine visual inspections, being sure that the maintenance of the equipment is being conducted appropriately, things along those lines. But in terms of your actual analytical monitoring that you're taking in the case of a cruise ship several times per year, then what you would be looking at is you would need to submit those data to EPA on an annual basis. So hopefully that helps address that question. Please send a follow-up if you have one. Okay, so the next question, I'm going to put this to Kate. When we're talking about monitoring requirements for bilge water, are we talking about 400 gross tons, or are we talking about 400 gross registered tons?
In that case, we're talking about 400 gross tons.
Great, excellent, thank you. So I have another question for Kathy here I'm going to send to Dave. And Dave, you may or may not know this answer. Several U.S.-based certification programs were noted in the presentation. Are there any internationally recognized certification programs which could be used to assess the ability of labs abroad to conduct sampling and or analysis?
No, I have to say that I'm not really familiar with that at all. I'm more familiar with U.S. certification programs, so I don't think I could give a really good answer for that.
Great. Thank you. And unfortunately, I can't either, and I'll look around the room. I don't know if anybody here can. We cannot, but as we went through earlier in this presentation, and once we have our reference document out, we will have a list of several certification programs out there where there is some independent quality control that really help, in this context, vessel operators select a good lab. Unfortunately, we can't necessarily provide that assistance for internationally located facilities, but if anybody on the call is aware of such certification programs, it certainly could be helpful to us and then also your peers in the field if you make us aware of that information. Okay, so this question is regarding the new build date. I'm going to ask Kate this one. Vessels constructed on or after 19th of December 2013, and I believe this is in regard to monitoring requirements. What if this keel was laid, say, October 2013?
So again, as we mentioned, some of the requirements kick in if you're considered a new build vessel. For gray water and for bilge water, that date is December 19th of 2013, and that means that your vessel was constructed on or after that date. So for whether or not that applies to you, I recommend you look at the definition of constructed, but that's triggered based on the keel laid date. So in your example, if the keel laid was in October, you would likely not actually be considered a new build in that case because your build date happened prior to the December 19th date of when you'd be considered a new build.
Great. Thank you, Kate.
Oh, and thus so the monitoring requirements wouldn't apply to you.
And just to be clear, if there's any ambiguity after these answers come, please feel free to send a follow-up question as well. So the next question, this is for Kathleen. Are there standard forms for the EPA required information for the record keeping on board the vessel for each discharge sampling? These were discussed as field notes. If they are available, where can they be obtained?
So there are no standard forms for field notes by EPA. These are typically forms that the labs create, or you can create and customize to document what it is that you need. I will have to say that chain of custody forms can be standardized, and generally labs will have those and can provide those.
Great. Excellent. Thank you. So the next question for Dave. Are there any specific requirements for the sampling points for sampling of gray water? So in other words, does your sampling access point need to be located in a specific place? And I'll add on to that question, Dave, as well. Based on your experience now, you're close to 15 years experience sampling gray water on board ships. Do you have recommendations for where it's easiest to locate these sampling ports if they're going to install them?
Well, for Alaska cruise vessels, that sampling point needs to be within 50 feet of the skin of the ship. That's really the most specific requirement, I think. For other vessels, it's really important, like I said earlier, if you have any kind of UV sterilization, you want to make sure that your sample point is at some point after that. The other thing that can be advisable, too, is if your system has the ability to either discharge overboard or discharge to a holding tank, that your sample point be some point where you could sample the flow of gray water under either of those two conditions. So the port would be somewhere before, let's say, a three-way valve that would divert water either overboard or back to a holding tank.
Great, thank you. So the next question, I'll take this question. Will the EPA be holding another session for sampling specific to ballast water at a later date? And I'll give you a two-part answer to that. The first is we are going to release some additional reference information in the near future for discussing the ballast water sampling requirements specific to the permit. And I'll just real quick reiterate what those are in just a moment. Second part of that question is we do not currently have one scheduled. However, we do intend to schedule additional webinars in the future. So if this is a topic that you would find beneficial, please be sure at the end of this webinar, when we do put forward the survey, please be sure to answer that as something you would like to see and would be interested in attending. So that's something we can definitely consider in the context of what's most useful to stakeholders. I'm immediately going to tie that in another question that I'm going to answer, and that is the question for ballast water sampling. How can somebody go through and do a enumeration of organisms based upon the sampling requirements EPA has in the permit? And though we didn't go specifically into the ballast water sampling requirements today, please draw your attention to the BGP fact. I draw your attention to the BGP fact sheet where we discuss these are really good indicators in the case of functional monitoring to see how the systems are performing that we would like to believe correlate to the actual performance of the system and it meeting treatment limits. We also have monitoring for some biological organisms, for microbiologicals, that do directly correlate. And then we also have active substance monitoring. However, the monitoring that's required will require a smaller volume of ballast water than the cubic meters that you may have been reading about or be familiar with in terms of doing some of the enumeration of ballast water sampling. And once again, we'll have more information on the sorts of sampling that's needed for the sampling ballast water for meeting the obligations of the permit. So the next question is specifically in regards to sampling of for the new build discharge samples for bilge water and for gray water, and I'm going to direct it to Kate. The question is, samples have to be collected for bilge water and gray water for new build vessels. What about when a vessel goes into dry dock?
Sure. So for gray water and for bilge water, again, it's not triggered by a dry dock date. It's triggered by your new build date. So I think if I understand the question correctly, would sampling apply to vessels after their dry dock date? Maybe I'm interpreting that as a ballast water question. Or that sampling may have to start occurring after ballast water treatment systems are installed. And then that would be when triggering ballast water is how I would have read that, but maybe Ryan has a different interpretation.
Well, perhaps that was the interpretation, and I misread it. So I'd ask the person who sent that question and send it in and ask for any sort of give us a little bit clearer question as well.
But I'll just answer for bilge water and for gray water, the dry dock date isn't sort of triggering when sampling would need to occur. It would just need to, for those vessels that it applies to, for new build vessels or for vessels operating in the Great Lakes, then that sampling would just have to be conducted once or twice per year as applicable.
Great, excellent. I'm sorry, give me just 1 second. The question I was getting ready to read just popped down on the screen. Sorry, we're having just a little bit of a system issue here, or maybe I'm having a me issue. Here we go. This question's for Dave. Dave, among lab requirements the ship operator should be asking, should one of those questions be that the laboratory has availability to pick up and analyze samples 364 days a year, 24/7 for the shipping business?
Well, I guess that really just depends on the operation of the ship. That's probably more than a lot of commercial laboratories are willing to commit to. But generally, if you provide a schedule of the ship and when they're going to be in port, laboratories are pretty good at coordinating times to meet and pick up samples if it's after hours. So, finding 24/7 availability is not likely just because of the personnel needed to do things like microbiology tests. But that being said, a lot of labs will be willing to arrange something like that in advance if there's an off time or a holiday pickup or something like that.
Great, thank you, Dave. So I will direct the next question to Kate. Do existing vessels have to require to modify for sampling? And I think it's kind of a two-part question depending upon whether it's for something like ballast water, exhaust gas scrubbers versus bilge water or gray water.
So for existing vessels that are required to do monitoring, so again that would be for vessels that are required to do ballast water monitoring or vessels that are required to do exhaust gas scrubber monitoring, there's not a modification that's required or a specific maybe technology requirement for monitoring. You just have to comply with, they said, the parameters that need to be monitored for and the frequency in which they need to be monitored for. For bilge water and for gray water, again for non-cruise ship gray water discharges, then those are triggered based on new build dates. So for existing vessels, they would not have to do anything to do monitoring for those discharge types. So again, for bilge water, unless you're a new build vessel greater than 400 gross tons, you don't have to worry about bilge water monitoring. And for gray water, unless you're a new build with a crew capacity of 15 or your Great Lakes vessel that's subject to that requirement, or again, if you're a cruise ship, a medium or large cruise ship, you don't have to worry about gray water monitoring for this permit.
Great, thank you. Okay, I think a couple of questions. We have some that are a little redundant, so we want to be sure that we get new questions. I'll go on and address one very specific question from Ginger, and then we'll have time for one more question before turning to the survey. Okay. Ginger asks, does analytical monitoring of gray water required for cruise ships in Part 5.1 and 5.2 of the permit need to be done by an approved lab? We do include language in the permit that needs to be done by an approved lab. And the reason that language is there is Coast Guard currently requires, as part of their implementing of Title 14, monitoring for certain cruise ships entering Alaskan waters, and they do require a Coast Guard approved lab. So rather than creating confusion between EPA's requirements for cruise ships operating in Alaska and for the Coast Guard requirements, we left that language as is in the permit. Please feel free to send us any additional questions on that or point out if we have any potential inconsistencies, and we, of course, can attempt to rectify that at a later date. So the final question, and I'm going to direct this one to Kate, and I may answer some as well. In the context of annual reporting of the data, the permit specifies that all monitoring data will be submitted annually and electronically. Does this include the continuous monitoring, e.g. the functional monitoring, for ballast water or scrubber operations?
So yes, that does. So as we mentioned, you are required to submit all monitoring data to us as part of your annual report. But we do understand you're going to have some systems that are going to be monitoring more frequently than a couple times a year where we have continuous monitoring. So you are required to keep a record of that continuous monitoring and submit it to EPA as part of your annual report at that time. So you don't have to submit it to us on a more regular basis because you have to do more frequent monitoring. It all can be submitted as part of your annual report.
Right, and this is where I will say I wish I had one of our brilliant IT guys with us because they can answer this question better. But I do believe we're building the annual report system right now to allow for the reporting of summary data to try to ease so you don't have to report every single discharge point every 2 minutes. So that is a tool we are trying to develop as far as I understand, and please feel free to send us any follow-up questions. So with that, I will close the question period here today. If you do have any additional questions, please send them to us at vgp@epa.gov. I'll caveat with that, we are currently running approximately a 1-week turnaround time on some of the simpler to medium questions. If it's a complex question, it's going to take longer than that. But please don't let that deter you from sending us questions. We'll do our best to get back to you. And right now, we're running about a 90% response rate in 1 week or less. So please send us those questions. With that, I will say thank you to everyone who attended today. Thank you very much to our speakers, particularly those taking time out of their busy schedules and other things. Not that everybody doesn't have a busy schedule, but taking time from their busy schedules to present to all of us here today. We will now turn it over to the survey.